Lesson 39, Part 1 is Common Core Standard 6EE3 and 4, Properties of Arithmetic. And this part of the lesson is an introduction to the properties. Go ahead and get your notes ready and push play when you're ready to begin. Okay, and this lesson is mostly a vocabulary building lesson, and some of these properties you've covered before in your previous grades, but maybe they're a little hazy. Maybe you were a little unsure, maybe it's been a long time and you've forgotten a little bit and we just need to dust off cobwebs. So I decided to cover all of the properties again just to dust off cobwebs and help you understand. But we will go into, in Part 2 and 3, more of the 6th grade level where we focus a little more on distributive property. So let's today take some time to put into our notes the vocabulary that goes along with the properties. So the first property I want to remind you about is the identity property. And there's two identity properties. There's the identity property of addition and the identity property of multiplication. And this one I remember because of ID. So like if somebody asks me for my ID, I get my driver's license out of my wallet, that's my ID, and I show it to them. And it has a picture of me that looks just like me. So identity property is about the number looking just like himself. So the identity property of addition would be, let's use the number 4. So what we'd want is 4 plus something that's going to keep 4 looking like 4. So what number can I add to 4 that's going to keep 4 looking like his identity, like his driver's license, his ID, 4? Well, there is only one number that I can put here that that will make 4 stay a 4 in addition, and in addition, that number is 0. So the identity property of addition is just simply that I can keep this number the same by adding 0 to it. That will keep the number the same. Easy, right? Easy. All right. Let's use 4 again for the identity property of multiplication. Now that you get the idea, you probably already know the answer in your head. What can I multiply 4 by in order for him to maintain his identity? What do I multiply 4 by so that he can stay a 4? Well, the only number I can multiply him by in order for him to stay a 4 is not 0, is it? Because then it would be 0. It's different. The only number I can multiply him by is 1. So 4 times 1 is 4. So the identity property of addition is that any number plus 0 is going to be that number. We can put that in letter terms. Any number plus 0 equals that number. And the identity property of multiplication is that any number times 1 is that number. So those are the identity property. That's all it is. It's nothing fancy. It's just that the numbers maintain their identity. Okay, the commutative property. You've heard me talk about the commutative property a lot. I mention it a lot in class because I use it a lot. Commutative property of addition works for addition and multiplication only. And basically what this means is that the order, as long as it's all addition or it's all multiplication, it does not matter which order you go in. For example, 3 times 2 is the same thing as 2 times 3, even though they're in different order. So 3 times 2 is 6, and 2 times 3 is 6. So you could say x times y is the same as y times x would be a good way to explain commutative property. If you flip them around in multiplication, it's okay. If you flip them around in addition, it's okay. It doesn't work in subtraction. It does not work in subtraction, and it does not work in division. You can't go flipping things around. They're not as free. But in addition and multiplication, you can. Notice here I've got 5 plus 3 plus 2, and then I've jumbled them all up, 2 plus 5 plus 3. Same numbers though, right? There's the 3, there's the 5, there's the 2, and it's all addition, so I'm safe. That's okay. I'll still get the same number because 5 plus 3 is 8, plus 2 is 10. 2 plus 5 is 7, plus 3 is 10. So you get the same number. Probably the biggest place, let's put that in letter form for your notes. So we'll say A plus B plus C is equal to C plus A plus B, or B plus C plus A, or whatever, however we want to move it around. We're allowed to because of the commutative property. Probably the biggest place I use this in is when I get something like this, 3 times 254. I look at the digits in here and I think, and you don't need to copy this part down, just kind of watch here. If I went in the order that it's like, I would do 3 times 254. And I don't want to do that because when you multiply, you have to have a row for each of the digits that are down here. So I'd have to have a row, 1, 2, 3 rows down here. And I don't want to do that. So I prefer to, knowing that it's multiplication and the commutative property allows this, I prefer to flip them around and do it this way. I guess if you wrote that down, that's okay. So I prefer to do that instead. And the commutative property allows me to do that. So commutative property is just mixing the order up, and it's okay in addition if it's all addition, and it's okay in multiplication if it's all multiplication. The associative property of addition or multiplication is, again, another one like commutative property that only works in addition if it's all addition, or only works in multiplication if it's all multiplication. And you have used, I'm certain you have used the associative property in your brain to make things simpler many, many times. I remember that it's associative property because of the little curve here, and the little curve here reminds me that it's dealing with parentheses. So it's just the movement of parentheses. For example, if I have 6 plus 4 plus 2 equals, and I have those in parentheses, equals 6 plus 4 plus 2. So the only thing that moved here, if you'll notice, I have 6, I have 4, I have 2, it's all addition. I have 6, I have 4, I have 2, it's all addition. The only thing I changed is where the parentheses are located. And what you might decide as you're working through a problem is go 6 plus 4 plus 2. Well, I can add those up, but I'd rather do this addition first because 6 plus 4 is 10, and 10 is an easy number to add. So if you're grouping things differently to make them easier to add in your head, you're using associative property. So, the associative property allows you to move those parentheses around, but again, only if it's all addition or only if it's all multiplication. So you could see that this would be equal. If you did 4 plus 2, you get 6. If you did 6 plus 4, you get 10. 6 plus 6 is 12, and 10 plus 2 is 12. Probably the biggest place I use something like this is, let's say I'm playing when I play cards, a game of cards with my boys. Sometimes you get stuck with cards in your hand and you have to add up how many cards are left in your hand, and I'll have something like 6-pointer and a 3-pointer and a 4-pointer and a 7-pointer, and I have to add them up. And so what I end up doing in my head is going, instead of counting all on my fingers, I kind of notice that, oh, 6 and 4 is 10, 3 and 7 is 10. I have 20 points in my hand. And essentially what I've done is I've just regrouped. So I've used commutative property by moving them around, and I used associative property by grouping them in the order I wanted so that I could just have simple math to do in my brain. So I use both properties when I do things like that. So you're probably using associative property and commutative property a lot. You just didn't know it, so that's the name of them. That's it. All right, and the distributive property, this one is probably my favorite because it allows for a lot of different little tricks and shortcuts that can make you seem like you're this big genius. So I'm going to show you a couple pieces of the distributive property, and then I'll show you how it looks with variables too. A lot of you use the distributive property a lot without really even knowing that that's what you're doing. I sit next to you while you're doing your math and your multiplication, and I watch you puzzle out something that that you didn't know by memory, and you're using distributive property. Here's what I mean. Some of you are still have not memorized like your 7s and 8s and 9s in multiplication. So you get a problem that's like 7 times 8, and you look at that and go, well, I don't know what that is. So I watch you do this. I watch you go, well, I know what 7 times 4 is. And I've got 8, so 4 plus 4 is 8. And you're not like writing it out this way, but this is what your brain is doing. And you say, okay, well, I know that 7 times, so if 4 plus 4 is 8, 7 times 4 is 28, so you do 7 times 4 first, and then you add it to 7 times 4, which is 28, and then when you add those together, you're getting 56. So this is all going on in your head, but that is the distributive property. You're splitting this number up apart to make it a smaller number that you can work with, and then you're doing the multiplication because you know your force. So that is the distributive property that you're using to help you. I also used the distributive property one time to impress my brother. We were doing multiplication problems with his son, my nephew, and finally my brother decided he would test me and see if I could do larger multiplication. So he started throwing bigger numbers at me, like 28 times 6. And so, we were doing it in our head, so he didn't think I could do it in my head really quickly. So really quickly in my head, what I did was I said, well, 28's the same as 20 plus 8. And I knew that 6 times 20 was 120, and I knew that 6 times 8 was 48, and I could easily add in my head that that was 168. So I did all of that in my head, and so he said 28 times 6, and I just took a few seconds to split those apart and put them back together, and I said 168, and he was surprised that I could do that. So you can almost seem like a magic trick because you're just pulling stuff apart and then putting it back together. And that's what the distributive property does. It pulls things apart, puts them back together for you. So let's look at just a few examples of the distributive property happening. If I have 3 times x plus 5, I can get this into a simpler form by multiplying 3. This is 3 multiplied by whatever the sum of this is going to be. I can't do the sum of this because of the x, but that's okay. I'll go ahead and multiply 3 times x, and that is 3x. And then I will add it to 3 times 5, which is 15. And I can't do much from there. I'm stuck there until I know what x is. But this is using the distributive property to pull things apart or put things together. I don't know, whichever the way you want to look at it. You can do the same in reverse. Oops, I need it to be a pen. Let's say I wanted to pull out a common number out of here, so I just had to focus on the lowest numbers possible. I can say, well, what's a number that divides into this and this? Oh, look, 3 does. So I'm going to divide it all by 3. Divide 3 out of there. So I'm going to pull 3 out of there, and then what I'll be left with, because 3 divides into 3 once, so you have 1x there, and 3 divides into 15 5 times. So now I have 3x plus 5. So you can pull numbers out, and so that you have simpler equations too. So you could go both ways with it, and it depends on what you need done. You can use the tool either way. You have been using the distributive property quite a bit during this school year when you use that broken ladder. That's exactly what we're doing, is pulling common numbers out of there. So if we had 15 and 25, you have been looking at this and noticing, hey, 5 goes into both of them. So that's the distributive property. You're saying, hey, 5 is a divisor of both of them. Let me pull that guy out of there. So basically what we had is, if we had 15 plus 25, you pulled 5 out of there, and you had 5 times 3 plus 5. That's the distributive property. That's what you've been doing. So so it's something you've been using, and you just didn't have a name for it. And we'll be using it in a lot of different ways over the rest of this lesson 39, and you'll get very familiar with it. But that's just kind of the introduction to the distributive property. And I'm going to stop this lesson at this point because it's gotten longer than I want it to. So review any of them you need to, get those notes in there. Today is just about learning what they are. We'll mess with more of the distributive property later.